Hello, welcome back. Today I'm going to be going over the component system design principle. This design principle can be applied to many different languages, but in this video I'll be using C# in Unity. I won't be doing any Unity specific code. This is just going to be using Unity as a vessel for the code essentially. But here's the timestamp if you want to skip just right to the code, but this is a pretty unintuitive at first system. So let's begin by looking at what you would usually do on first instinct when you're starting college maybe, or even someone at a company is going to just think that you're going to use extension. So class extension is when you have a base class like this one, person. You have some traits that feel like they're shared between people, like a name, a hair color, a height. And here's the constructor, the base constructor. Now, here's an employee class that extends person, and an employee will have years of experience. They'll have a PhD, maybe not. It's a Boolean, whether they have one or not, and the year's experience is an integer. So here you could see that the constructor has, it takes the name, the hair color, the height, the year's experience, and the has PhD, and it calls the base constructor for the things that are in the base class. And this feels like a pretty nice and understandable system, and that's because, you can look at it and say, well, okay, all employees are people. You can cast them to each other, but you encounter a bit of a problem when you have a big group of attributes that someone can have. Now, this is where I bring you to this lovely stock photo, okay? And try and put these people in code. That's my challenge to you. Try and put these people in code. What you'll find is if you try and use class extension, it gets really, really unintuitive. Let's just get some aspects about these people so we get an overview. So this guy right here, he has children. Of course, I don't know if the guy actually has kids, but we're going to go over some aspects. So he has kids. This guy wears glasses. He's wearing them in the picture. This woman has piercings. She has ear piercings and a nose piercing. This woman has years of work experience, so maybe she has a bit of a resume that matters. And this woman right here is married. Now, I don't even know if that's a wedding ring, but it doesn't matter. For the sake of for the example, we'll say that these are some aspects about these people. And of course, they share aspects. Like this woman has earrings. This woman has, her ears are covered, so we don't know. But this man has earrings too. And, this guy might be married, but it doesn't matter. Let's go over how we would fix the code. Let's fix these issues in person. So how about, okay, let's put is married. So maybe we're done after we add is married, but oh yeah, the woman has a job, so maybe, we'll make her an employee. We can have the employee extending class, and that will fix that. Oh, and this code even forgets to take whether they're married or not. So that's another logistical bit that that would not compile. Okay, but let's move on. Maybe we can fix this. The guy has kids, so we have to add a list of children. Maybe if the person doesn't have kids, we'll just keep the list null or at count 0 or something. And oh, the guy on the right, he had glasses. So let's not forget to put whether he has glasses or not. So, the person wears glasses. But of course, I almost forgot. We have to put whether what the prescription of the glasses are. So, you have all the information. This sucks. I'll just say it. Look, you have all these different attributes that might not be shared between the people. Imagine someone who doesn't wear glasses. Their prescription is just going to be -1 or 0 or 999,999, maybe the max value for int. And you're going to have to deal with all of these things, and just so much data, and it's all unnecessary. And that's not even starting whether the person has kids or is married or even has hair. Who would have hair color if they don't have hair? That's why we're going to look at the design principle for components, or as they're called here, facets. We have an interface. The only function in that interface is a function clone, so that we can clone it. But let's get some examples of a facet. Maybe we have a facet name, F name. Maybe we have a facet F married. And you're like, well, Boolean works as married because you can tell whether the person is married or not based on the Boolean. Well, I say, imagine you have a list of facets, and if you look and they have an F married facet, you know that they're married, and then look at all these attributes you can have. This one might only have a string name, but this one has a year for the year they were married, and this one has a string for what metal ring they have. And of course, don't forget the clone. And I'll go over this in an actual IDE. I'll go over this in Visual Studio. But let's go over another important one. Look at this. F hair attributes, facet hair attributes. We know the color, the length, whether it's curly or not. We have a clone function. And most importantly, if the person's bald, we don't even need to add the hair attributes to their list of facets, which brings us to person. Look at this. We have a list of facets called attributes and a couple of great functions. Bool has facet and the generic get facet of a generic, and a clone function, of course. But the most important part is that if you compare this code to this code, it looks way better. All of these different facets that you'll end up writing, they might not be in a certain person, but you can make any combination. Make someone that has a name and is married and has hair, someone who's has a name and is married but doesn't have hair, someone who's not married, so you don't add the married facet, so they just have a name and hair. This is where we're going to get into the code. I'm going to go into Unity here, and I'm going to make a script. Now, this is not going to be a mono behavior. I'm just going to have a script called person utility. I'm going to open it up. And I'm going to clear everything. Now, maybe in some tutorials they'll have you clear the body. I'm going to clear everything, the entire class, and actually I'm going to write public namespace person utility. I'm going to pull this out so that I have a... So, this person utility right here is a namespace. Sorry, it can't be public. The namespace person utility, just like that. And all of these are namespaces up here. If you've never made your own custom namespace, all the namespaces above here they just have different aspects, and that's what a namespace is. So in another script, you'll say using person utility above to notify the script that you're using their aspects. But let's go over the actual code. So just like the presentation, we're going to have a public interface facet with a public facet clone. Then let's just make some facets over here. Let's have a public class fName, which is a facet. And of course, you're going to need a public fName constructor. I'll pass a string name. I'm going to need a public string name that gets set in the constructor, and of course, public facet clone, which returns a new fName passing name. Pretty straightforward. I think it's word for word what was in the presentation. Let's do one more, and let's grab public class fMarried is a facet. And we'll have a public fMarried, and we'll have two things, int year and string ring metal. And we'll say public int year, public string ring metal. This dot year equals year. This dot ring metal equals ring metal. I'll do one last one after making the clone function, but these facets are up to you. You can use the system for people, for items in your game, for animals. All of these work with this system. It's a very robust system, even though it's pretty short in the code, which is also nice. So we'll return new fMarried. See, the code is eager to autocorrect. We'll have fHair attributes, which is a facet. We will have a public fHair attributes, and I think that I had string color, a float length, and a bool curly. Public string color, public float length, public bool curly. This dot color equals color. This dot length equals length. This dot curly equals curly. And then again, don't forget the implementation. Again, here's a trick in the editor. You can type control plus period, and then you can hit enter for the top result of its suggestion. It'll usually suggest well. So we can return a new fHair attributes passing color, length, and curly. Okay, so now we have these attributes that we actually need to put inside of a person. So let's write the actual person class here. How about public class person? And we'll have a list of facets. Then let's write some constructors. So public person, we won't have a string name. Instead, we will pass a list of facets. And we'll say this dot facets equals facets. Okay, now here's another pretty nifty one. You can say public person, and then declare params, which stands for parameters, facet array, facets. Okay, so what is this? Basically, it's going to let us put as many facets in a row without making an array locally or a list locally. We can just pass them in, and I'll show this in some example code later, but this just makes it a bit more legible. But of course, you have to call the constructor that takes a list, which is the only other constructor. We'll do facets.toList. So it'll convert it. And then, of course, open close parentheses. You can do stuff in these parentheses, but in this example, we don't do anything. All right, so let's get some important functions down. For example, public void, add facet, facet. We'll say facets.add facet. Then we'll say public void has facet. And now this is where it gets a bit interesting. We're not going to pass any variables, but we're going to tell the function what type, using a generic, we're looking for. And now we only want to be able to pass specifically facets. So as the computer is saying, you say where t has to be a facet. Otherwise, it's going to hate it. So we're going to write right here, return get facet of t does not equal null. Now we don't have a function called getFacet yet, is what we're going to write right here. But basically, we're going to have a function that returns null if it doesn't have a facet, and it returns the facet that you're looking for if it does. So we'll have a public, and this is not a void actually, my mistake. This is a Boolean, bool. This is a generic T, get facet of the generic, where T has to be a facet. Okay, so how about for each variable facet and facets, we're going to say if, and this line is going to look a bit strange. But I'll explain exactly what this means. This means if this facet that we're looking at, we look at each facet in the list, but if the current one that we're looking at is an instance of the type T, which is a generic, you're going to pass something like fHair attributes or fMarried. This is the same thing that you do in Unity that you say get component. For non-Unity users, you can ignore that, but for Unity users, it's actually really understandable, and it's really easy to use the system after you've made it because it's just like saying get component. You put the component in the little caret brackets and you get the component. So you put them in the carets just like get component. So we're going to say if it's a type of the type you passed, we're going to return the facet cast as that type. We're casting it as the type. So we're not just returning a generic facet, we're returning specifically that type. So we'll return a hair attributes or a name or something. Otherwise, if none of them, we're returning default, which will return null here in this instance. Okay, we're almost done. The last thing is public item clone. Oh, sorry, person clone. We're cloning the person. And now this is because if you don't have a clone function and you make an instance of a person and you set another instance equal to that instance, you're going to end up with all the references to a person in your code pointing to one person in the memory. And you don't want that because if you change one, you're going to change them all. So public person clone, you're going to say list of facet, facets copy, equals new list of facet. Now, if you have some fancy syntax, you can copy the list that way, or you can just copy it in the classic for each var item in collection, facets copy.add facet. Now you say person clone equals a new person, and you're going to pass in the facets copy, and you're going to return the clone. Perfect. This, to give you an idea, besides the facets, which you'll have to write on your own, this person class, or item, depending on what you're doing, person, item, entity, this is it. Line 66 through 112 to 113, around 40 lines will cut down on all the unnecessary extensions that you have made, all of these attributes. Now, here I'll show you an application, okay? I'll show you an application. If we remove some of these unnecessary usings, namespaces. Well, I'm going to go back to Unity. It's going to compile the script. And let's just make a random script called foo, and we'll go in here. And this, if you import, say, using person utility, you can just say person, right? You can declare the person, but I'm going to show you how the two different ways you can use this. Now, you can have a person in some function, public void bar. It's just an example. Say person equals new person, and we'll just pass some variables like new fname, and we'll pass a name, Laura. And we can pass a new F married. She was married in 1997, and her ring is silver. Okay? Maybe we make another person. We say person Bill equals new person. And let's say Bill has a name. I mean, Laura doesn't have hair in this example. But we'll say Bill has a name, Bill. And how about he has hair attributes right here? And we'll say that his hair, let's open up the thing, string color, so he has brown hair, and the length is arbitrary, we don't have a unit, but we'll say 1, maybe it's a foot long, that's wild. And it is curly. Now here's Bill, and we'll rename this person to Laura, and now, you can have a list of people, wow, that's pretty good, the autofill, people.add Laura, people.add Bill. Look at that. You could just add Laura and Bill to the list of people, and they're treated the same. Now, this is, for people, I think this is a very straightforward application, and then you can do different things with these. You can say, oh, well, if the person doesn't have hair, then we won't prompt them to be able to buy shampoo or something in the game maybe, or in the utility program that you have. But I'm going to show you an example where you can streamline this process. I'll go back to person utility, and let's add a new facet. So making a new facet is as easy as saying public class F employed facet. Okay, so I'm just going to copy this so that we have some attributes. Just I have to write less. I'm copying the hair attributes. I'm going to make it the constructor accurate and the clone F employed. And I'll have a string job title. I'll say this dot job title. And I will say, instead of a float lang, I'll delete curly. I'll say bool int years experience. Experience equals years experience. Say this and have a public int years experience. Okay, well, we have this F employed, and what if we know that every employee in a company is going to have a name and be employed. We know those things. For sure. Definitely every single time. So you can go anywhere, and I'm just going to do it in the person utility namespace because it's fitting. But I'll have a public class, and when I have items in a video game, I'll name it like item catalog or all items or something, but we'll name this person constructor. Or if you want to make it a bit better, maybe person or people, right? Just name it people. And this is where it gets interesting. We'll have a public static. We'll make this class static as well, because we never want to make an instance. We'll have public static person employee. Now, we know, let's say the employee is going to take string name, string job title, and int years experience. So we go in here and we can say, well, I'll return a new person with new F name, passing name, and new F employed. passing job title and years experience. How's this useful? Well, let's go out here and let's go down here and say, okay, well, let's delete these actually. Let's say person, Laura equals, and then we go in and say person, people. I'd say people catalog sounds a bit strange, so I just named it people. But you would say people.employee, and then pass Laura, and then her job title. Maybe she's a human resources. I don't know. Maybe she's an engineer for a company. But let's put human resources. And she has 15 years of experience. She's seen it all. Now, it'll automatically add a bunch of these things. And maybe, you want to say, okay, Laura dot add facet. We want to add a facet to Laura. She is also married. So let's put she was married in 1997, and it's a silver ring. Okay. We can also say Laura has hair. Okay, now Laura has brown hair, and it's 2.5 feet long, and it is curly. So now Laura has these attributes. We want another, employee. We want Bill back, and he's also hired, and his name is Bill. And we pass. I don't know. Maybe he's also human resources. Him and Laura know each other. He's a bit less experienced. He has only a decade, right? But he's bald and unmarried. But don't worry, it's fine. Everyone is having a good time. Now, we have all of these different uses for these people, but let's just go ahead and put this in start so we can actually have a bit of application. And I'm going to give Bill and Laura some coworkers. So Stephen, Will, Chanel, and how about Amelia? Now we're going to name these people Steve, Will, Chanel, and Amelia. And we're going to, how about Steve is he's the company plumber. There we go. He's a company plumber. Will and Chanel are both computer engineers. And how about Amelia as a project manager? Well, let's give them varying years of experience. It doesn't matter. So how about he has 20, they each have 12, and Amelia is a manager, but she's good. 7 years. She swooped into the scene. Anyways, let's make a list of person, people, and let's just add everybody into the list. And now, all of these people, they don't have hair, except for Laura. Everyone's bald. So that is irrelevant right now. But we'll make it relevant. How about we will add hair to, we'll add dark brown hair. It's 0.3 feet, and it's curly to Will. And how about Chanel can have half a foot long black hair? and it's not curly. So all this is to use as an example. So let's go for everyone in people. Let's say if people of I dot has facet f hair attributes, we're going to say people of I, we'll say debug dot log people of I dot, and then this is going to look a bit strange, but I'm going to put a question mark. It's it says, well, okay, if this isn't null, we're going to grab their name. Otherwise, we're just going to put nothing. And now this means that if you have someone without a name, it's going to put no name, which we don't have here. But this is just a useful operator to know. This asks, okay, it just replaces an if statement that says if the person dot get facet is not equal null, blah, blah, blah. Yes. Okay. So we have all of this. And we can go in here. And if we hit play in Unity, it should debug Laura and Will and Chanel. So let's look at Unity. Let's put a foo object into the scene and add the foo component to it. And we're just going to play, and it will debug. Laura, Will, Chanel. There you go. And that's one of the many different things you can do with this system. This was just a bit of a, just an example. But last thing is this operator is really, really nice to know. So let's just remove, let's say, let's make a person with hair, but nameless equals, but they don't have a name, and I'll add nameless. This is just to show off this operator. It's like a turn. It's sort of it's in the genre of ternary. The ternary is the question mark and the colon for Boolean functions. But if we play, it should say Laura, Will, Chanel, no name. There you go. Well, I hope you enjoyed this tutorial. And one last thing quickly. This is also in addition, this is just the cherry on top, is if you have people like with the same name, or you want something that is really, really distinct, you should make a private read-only string ID. And then in the constructor, you should say this.id. You could just say ID, but this.id equals GUID dot new GUID dot toString. And there you go. You're going to have this. And you don't need to worry about copying it over because you want the ID to be different for every instance of the object. So that's completely fine. You have this ID, and also so you can actually access it, you should have a public string get ID, so you return an ID. Really nice for sorting, just to give you an idea. And how about let's do this. We'll do the person's name, and we'll also debug, we'll debug this in addition to a space, and we'll say people of I dot get ID. And everyone has an ID. That's the one thing that everyone has. Even if it's a blank, empty person, they're going to have an ID, and it's going to be different every time. So don't worry. Every time you run the game, they're going to be different. That's not something you have to worry about. If you're like, oh, something's going wrong, no, it's not. So this is what an ID looks like. It's just a really long string. But yeah, that's the cherry on top of the system. Hope you enjoyed the tutorial. Hope it was helpful. And I almost can guarantee you that if you implement this in a project that's sort of complex, it will cut down on the amount of code you're going to end up having to write, because this is so nice. This is super compact, and you don't have to worry about contingencies. Oh, I want an employee, but also the employee is married, but the married person is also an extension of a class. How am I going to do that? So I'm going to have to make it married employee. So it's just not worth it. It's not worth using class extension when you can use this, the design principle of components. All right. Have a great rest of your days, and happy coding.